Okay, well, we're going to try finding the derivative of a function, and we're going to look at the function x squared. But this time, instead of finding the derivative at a point, we're going to find a derivative for all values of x. That means I can know the derivative of f of x at x squared for any point. So let's use this definition of derivative, since this is the one we need a little bit more practice with. And I am going to find the derivative at x for all values of x. So how this would work then, we will have the limit as h goes to 0, and the function is x squared. So it's going to be the quantity x plus h squared minus, then it's x squared all over h. So you notice the only difference in what I'm doing right now is I'm using x instead of using a specific point, okay? Or a specific value for x. So let me go ahead and now use my algebra skills and simplify this limit. So the limit as h goes to 0, and I'll expand this so I get x squared plus 2hx plus h squared minus x squared all over h. And so then we notice the x squares reduce out. Beautiful. So I'll continue my simplifying process. The limit as h goes to 0. And I notice that there's an h in common here. So I'm going to factor that out of the numerator. So I get 2x plus h all over h. So then the h's reduce out, which is great because otherwise I would have indeterminate form. And now I'm going to go ahead and plug in the number 0 so I can stop writing the limit notation. So when I substitute 0 for h, I end up with 2x. Well, what does that mean? That means that the derivative of x squared, okay, so let me graph x squared, at any point on this function, I can find the slope of the tangent line by using the function 2x. So in other words, when at x equals 0, the slope on x squared, so this is y equals x squared, will be 0. So the slope is 0. That makes sense. Let's try another value. So like at x equals 2. Well, 2 times 2 is 4. So at x equals 2, the slope would be 4. So 2 is about right here. Okay, that makes sense because it looks like it's positive and it looks a little steeper. Let's try another value. What about at x equals negative 3? Well, at x equals negative 3, the slope will be a negative 6. Okay, so here's maybe negative 3. Well, let me get my pen. And the slope is a negative 6. Okay, that is working. Well, what if I graph the derivative of x? Well, the derivative of x is a line with a slope of 2. So something like this. So this is the graph of the derivative of x, which is 2x.